This is the Mooncast. So let's talk computer fundamentals. So today we're going to be trying to break down the different elements of computers and stuff like this. And as you guys know, I am getting into cybersecurity. So I am beginning to study for that as I'm taking a Google course right now. So I just want to break down the different things that I'm learning over the course of that time with you guys and share my experience with you guys on this journey and how it's going. Because a very, very interesting skill set that I think will be more and more needed throughout the course of time as more and more people get on the internet. Right now we have an estimated amount of 4 billion people, and that's supposed to increase to 5.5 billion people by 2030. And by 2050, around 95 to 99% of people are supposed to be on the internet as internet infrastructure continues to get built out over that course of time. So I just think this is a very, very important topic that a lot of people aren't really talking about. And I really just want to address it and also at the same time be able to give valuable information about cybersecurity, because I think a lot of people don't really know what it is and what it's about. So I think we'll just start from the very basics in regards to computers and things of this nature. And I hope you guys enjoyed this and find this content valuable. So first things first, I want to note is that nearly 75% of all legitimate websites have unpatched vulnerabilities, right? Crazy. So basically everything is hackable, right? That's, I would say, not even 75%. I would say damn near almost every single system and operating system can be hacked into in one way or another, right? And you got to look at it from the perspective of the three separate different operating systems that we have, right? Which are, well, the three major ones, right? Which are Windows, Mac, iOS, and Linux, right? And Mac, iOS, and Windows are closed source, right? While Linux is open source. So that's something that you really want to pay attention to, right? And because when something is closed source, that means that you don't know about all the different vulnerabilities that could be happening within that closed source operating system. That's why in Web3 we emphasize open source operating systems, because those ones are the ones that have the least possibility to be hacked, because everyone can see the source code and they can pitch in to patch up any vulnerabilities before hackers may be able to get inside, and they can contribute to add to the code, right? And over the course of time, it just builds a strong, more refined source code, right? And so another topic right here that I wanted to discuss with you guys is the attackers reside within a network an average of 8 months before they are even detected. So usually these guys are already preying around different networks, right? And before anyone even detects them. So that's how much of preparation that they have. So by the time they finally want to attack, that's not the time that they actually attack. They've prepared. They've already gotten in somehow internally, whether through social engineering or pretexting or some kind of version of that, right? And they're able then to get inside, these network systems and these computer systems in these organizations and, attack the networks, and this is very bad because if you look at some of these networks are huge. If you look at some of the hacks that are going on, from Microsoft to Amazon, everyone, Facebook, there's a lot of different things that are happening in regards to attackers finding different nuanced ways of hacking. Even if you have the best software out in terms of malware protection and things of this nature, you can still get hacked through social engineering, where people can get passcodes, things like this, and from regular employees that work there, and they can leverage the password or passcodes, to brute force their way into the system in other means, and by, if they're able to imagine if they get access to someone's computer, right? They can then type in an email to someone else to then maybe make them click into a link that it has some malicious malware attached to it too as well. So these are things you need to be thinking about in regards to cybersecurity, right? So another bullet point that I want to talk about is that 89% of all cyber attacks involve financial or espionage motivations, right? So when these guys attack, maybe sometimes they'll do some things like some ransomware, right? Where what they'll do is they'll encrypt all of the company's data, and once all that data is encrypted, the only way that you can get access to your data is by paying the ransom fee, which is usually in Bitcoin, which again strengthens my argument again for Bitcoin, because companies, one way or another, are going to have Bitcoin reserves in case these attacks happen and there's ransomware involved. And usually, like I said, these attackers usually ask for Bitcoin, because if you deposit Bitcoin into someone's wallet, you don't know who they are. There's no KYC involved. It's very hard to track that, right? And they could spend their Bitcoin now. If you look at what's going on in El Salvador, where it's legal tender there, so there's really so many different ways in which they can bypass the fiat system and be untraceable and continue to spend money and spend funds in different jurisdictions around the world, where now, as I said, Bitcoin is starting to become more legalized. And right now, just El Salvador and Central African Republic, but I think over the course of time, there'll be a few more countries that are going to legalize it as make it legal tender, not just legalize it, but make it legal tender, which means it's actual currency within the confines of a nation state, right? So when we move on to the next piece of bullet points, right? So we look here, we see vulnerabilities lie within 3 areas, right? So the technology is where the vulnerabilities lie, and then the configuration, right? And also the security. So the technology aspect of it, we're talking about the actual hardware, right? The hardware itself. So there might be a bug within the actual hardware before it gets released. Like I think you guys have seen in the past too as well. I think it was Samsung, where they had a phone that was blowing up randomly or exploding. So sometimes there's faults within the actual technology, and it hadn't been patched up before it gets released out to the public. And then other times too, you'll see that there's configuration issues as well with how the systems, the softwares are getting configured, and there might be patches within that process of configuring certain softwares or systems into a network operating system, right? That's part of an entire organization, right? And then also there's a security element too as well, which again, like I told you, they can leverage social engineering, or people don't have proper security implementations put in place. They don't have the proper seams, right? When you're talking about the sort of tools, the tooling, right, which we'll get into in a later podcast, right? We're talking about the seam tools, right? But for now, we're just trying to keep it very basic. We're going to start talking more so about the computers, because I really want to get you guys a little bit more computer literate for those who are not. But so when we go down here, you can see 3 main components of a computer, right? So now we're talking about the hardware, which is one of the main first and foremost components of a computer, right? So when you look at it and you see what are the components of a hardware, well, you have the CPU and the RAM. So the hardware is kind of like the layer 1, right? When you're trying to compare it to, blockchain, because I think this is a very good podcast to put out, because I think a lot of people, they invest into crypto not understanding that you need to have some level of technological literacy, right? Or computer literacy to be able to smoothly integrate into the crypto economy, right? And so for me, this is why, again, I'm putting this out. So I really want you guys to pay attention to this, because yeah, a lot of people might know these basics, but I think a lot of people don't. So when we talk about CPUs, right? So computer processing units, right? We're talking about handles. What does it do, right? It handles the instructions you give to your computer, right? And that's basically what the CPU does. It's very simple, right? So it handles the instructions that you give to your computer. And so when you talk about RAM, the other component of the hardware, we're talking about random access memory, right? And what we mean by that is, what it does is it stores the data, and computer stores the copy of them in the internal hard drive, right? So it stores the data for you, and the computer again stores a copy of that data in the internal hard drive, right? So the amount of memory that can be used at one time, right, is the RAM, right? If you use too much memory at one time, it can slow down the computer drastically, right? And that's basically what it is. So the amount of capacity for processing different things that you're doing on the computer is the RAM, right? So when you're processing too many things, you have too much things open, that's taking way too much gigabytes, right? Which we'll get into later on, what the difference in gigabytes and kilobytes and megabytes, right? So when you're processing too much of it, the RAM slows down, which ultimately slows down your computer. If the RAM's capacity, let's say, is 4 gigs instead of 8 gigs or instead of 16 gigs, right? The bigger the RAM, the more you can do on your computer. For instance, when you play video games, it requires more RAM to be able to play video games more fluently, like if you have video games on your actual PC, because video games take a lot of gigabytes to process, right? And so that's why it's required to usually get a gaming laptop or something 16 gig RAM and up, right? To be able to have a more enjoyable user experience, right? And so as we scroll down here, we can see that a 32-bit can only hold 4 gigs of RAM, right? So remember that 32-bit computer, right, can only hold 4 gigs of RAM, right? And 32-bit systems or processors refers to a computer or microchip that uses 32 bits to represent and process data, right? In similar terms, think of a bit as the smallest unit of information in a computer. So super important to know, right? When you're talking about computer literacy, right? And then the 64-bit systems, right? Those hold 4 gigs of RAM and more of RAM, right? They can hold way more than 4 gigs. So 4 gigs is the minimum they can hold, and they can hold way more than that. So just to give you guys a more of an idea, right? So it's very, very beneficial to usually get a 64-bit computer, I think, because it just has you can get better processing speed because the RAM you can ramp up the RAM. And that's another thing people don't know is that you can change out, not all computers, but a lot of computers, you can change out the RAM in the back end of your computer when you're looking at all the different electronical hardware. You can actually swap out, say for instance you had 8 gig RAM, you can actually swap that out to 16 gig RAM yourself, so that way you don't have to pay for another computer because it's slow, air quotations, right? Same with the memory, right? The memory itself. So you can increase the memory capacity of your computer, right? So as we scroll down here, you can see RAM holds all active programming on a computer, right? And so another thing that's an important piece of information about computers, right, is the motherboard. So the motherboard is the main printed circuit board with a computer, which enables communication between other electronic parts of a computer, right? So it helps you to communicate. It's basically the central hub that is the interoperability communication solution for all the different components within the computer, right? It contains the BIOS, right, which we'll get into, right, the BIOS, and the CPU, right, the microprocessor fits into a socket on the motherboard, right? So when we scroll down here, you can see it enables also the connectivity from all devices, right? That's what the motherboard does, right? So the second important part, remember, these are the 3 main components of a computer, right? So the second important component of a computer is the operating system, which again, I've highlighted here, L2, right? So it's basically the L2, the layer 2 on top of the layer 1. Layer 1 is the hardware, right? And layer 2 is the operating system. So the engine basically makes that thing run, right? And so the hardware, if you're looking at it from the terms of a car, the hardware would be the car itself, the wheels, the exterior, and all these different components, right? And the operating system would be the engine and the transmission and things of this nature, right? And so when you're looking at the 3 major operating systems, you have Mac OS, you have Windows, and you have Linux, right? And people are familiar mainly with Mac and Windows. That's what most people use, but Linux is also very, very popular for open source technology. And the cool thing about Linux is that it's free, right? It's open source. If you know how to leverage it, you can use it too as well. And so when we scroll down here, so you see now, again, we can talk more about the BIOS, right? So that's the basic input-output system, right? So the program a computer's processor uses to get the system started when powered on, right? So basically, again, I'll repeat, the program a computer's processor uses to get the system started when powered on, right? So this is what gets the system started and powered on. Your operating system allows you to work on your computer like a middleman between the application and the hardware itself, right? This is the kernel, right? So the kernel is the middleman between the application and the hardware itself, right? And so when we're looking at the ports, right? So again, it's important. So a port is a number that lets the operating system know how to route the information and is assigned to different protocols such as email, right? So the operating system needs to know how to route the information because information is traveling through this internet protocol, right? And so the port, right? It lets the operating system know how to route the information, right? And so, for example, right, most email traffic across the world is assigned port 25, right? And most web browsers or HTTP traffic is assigned port 80, right? So any kind of information that's email is always going to go run through port 25. And so web browser HTTP traffic is assigned port 80, and secure browsers HTTPS are assigned 443, right? And so that's basically the different routing mechanisms, right? And so these ports allow the computer to identify what is email or web data, right? And so here you go. So as we continue here, we can see what did I write here? It says, now that your OS knows the type of traffic, it can route it through the correct server. Yeah, exactly. So once your operating system knows the type of traffic, right? So it needs to know the type of traffic. So it needs to know, okay, is it an email? Is it going to be port 25? Or is it going to be a web browser? Or is it going to be a secure web browser? So is it which is port 443, right? So it needs to know that. And there's also 4 stages of computer processing that you need to know. So the input, processing, output, and storage. These are the 4 main elements you need to know, right? For that particular component, right? When it comes to the 3 components of computers. So as we scroll down here, we can see the applications. So that's the layer 3, right? So that would be like dApps in a blockchain, right? So the layer 1 is the underlying protocol like Ethereum or Cardano, smart contract layer 1. Layer 2 would be, let's say for instance, like the Polygon. Polygon is layer 2 on top of in this particular instance, right? Polygon would be layer 2 on top of Ethereum, for instance, to help it more scalable, and the applications built on top would be more of like a layer 3 because they're using Polygon, they're leveraging Polygon. I don't want to make this too complex. Basically, they're leveraging Polygon because there's too much network congestion at layer 1. So when you move into layer 2, it's able to streamline the transactions at layer 2 and then finalize them back at layer 1. So as a dApp, it just makes more sense strategically to deploy on layer 2, meaning that you're more of like a layer 3 without the addition of validators, right? But anyways, I don't want to make this too complex, right? So when we're looking at the layer 3 applications, right? So you see here apps built on top of the operating system, right? So you're talking about Google Chrome, Excel, etc., right? These are the applications built on top of the layer 2. And layer 2, like we already discussed, is the operating system like Windows and Mac iOS and Linux and stuff like that, right? So moving on to servers, right? So server is a computer program or device that provides services to other programs or computers, right? Very, very simple. And so when we go down to cloud security, right? So we talk about the virtualization, right, of things, right? So virtualization of everything allowed applications, operating systems, and hardware to separate, right? Because of the capability of virtualization, right? And because of that, we were able to have IaaS, or infrastructure as a service, and we will support firms for a fee, right? So infrastructure as a service is basically it's basically similar to kind of what these like Amazon Web Services, right? What they do. So they say, okay, we can build the servers and then you rent the servers from us. So you rent our infrastructure and we take a fee. And that's basically what that is, right? And then you also have the platform as a service, right? So where people, have platforms that you can go on and you can leverage that to communicate with other people. When you look at YouTube or something like that, right? And then you also have this other business model of SaaS, right? Which everyone knows is software as a service, where you build some kind of software and people can leverage the software and they pay a monthly fee to leverage the software, whatever that is. You got Netflix, for instance, is a good example, right? People pay a monthly recurring fee to be able to have access to watch movies and TV shows. So some of the task network security protocols are commonly used for, right? So these are the common tasks for network security protocols, right? It's files transfers, web communication, and virtual private networks, right? So just so you guys know, and then here we see the secure file transfer protocol, right? And this offers a more secure way to transfer files. It's built on a secure shell, or SSH, and is able to encrypt commands and data transfers over a network, thereby reducing the likelihood of interception attacks, right? So SSH, as we continue on here, you can see, so SSH is a network protocol that allows you to securely access and manage remote computers, right? Or servers over an encrypted connection, right? It provides a secure way to log in, execute commands, and transfer files between your local and remote machines, right? And this is basically using the command line interface, which is part of Linux, right? Which we'll get into later in these after hours, right? So it's just the beginning, but we definitely will get into that in the after hours, right? But for now, that's basically all you need to know in regards to that. And then a virtual private network, or a VPN, creates an encrypted connection over a less secure network, right? So if the network is not that secure, you can create your own connection, right? Your own private network, such as a public Wi-Fi hotspot, for instance, or the internet, right? Often businesses use them to enable employees to securely access sensitive data, right? Because when that data is getting transferred, someone can maybe get that data, right? Extract that data in another means or another way, right? So it's important to have these virtual private networks to securely be able to transfer the data and give it an added layer of protection when you're talking about big organizations and so on, right? And so when we move on here to the 3 layers of security, so those are firewalls and antivirus protection and encryption, right? So the first layer of security, right? So basically ways in which, so how to protect yourself from hackers, essentially, right? And so a firewall manager sets up rules the firewall uses to filter unwanted intrusions from the internet. So it tracks data that's going back and forth, right, within a network. And whenever there's a spike or something unusual happening within that trackable data, it then alerts you, so then you can then go check it as a security analyst, for instance, right? So the wall shuts any non-essential ports a hacker might probe for openings, right? So basically anything that's non-essential, and remember, ports again is the emails, the browsers, and the secure browsers, HTTPS, which is 443, and emails again 25, right? So the firewall manager might block all inbound traffic except for email or data that someone inside the firewall has requested, right? So again, it just gives you the added layer of security so you don't get unwanted traffic sent into your network systems, right? And so firewalls and antivirus protection, right? So antivirus software detects and removes computer viruses and malicious code, and that's basically what it is, right? And yeah, we'll get into that later, but for now, it's all basically you need to know. And also then you have encryption. And encryption is very, very simple. So it provides protection for data susceptible to eavesdropping attacks, password crackers, or manipulation, right? And so data basically gets transferred, and only the person who has the encryption key or encryption code is able to access that data, right? And, I don't want to get so much into cryptography, but cryptography is also encrypted in the sense that you're sending data through the blockchain, right? And the data gets transferred to the person that you want it transferred to, and only those people who have the access to that wallet, in this case, when we're talking about cryptography, have access to then the newly transferred data or value, right? And that's basically how that works. And yeah, so that's basically encryption. And it says, remember, it's not enough to simply deploy these protocols. These must be maintained and remain in compliance to ensure that the risks are managed, right? So at all times, you need to always be updating the system, updating the firmware, and managing those systems, right? To make sure that they're in compliance, right? So when you look at the local area network, what is that, right? So it's a network of devices located and managed within a small geographic area, such as a home, school, office, building, or a group of buildings, right? So it's a smaller sort of network, right? So most encryption algorithms can be broken and the information can be revealed if the attacker has enough time, desire, and resources, right? So that's something you need to keep in mind, right? If there's enough resources, anything can be hacked into, like I previously stated in the beginning, right? What you want to do is be able to mitigate that risk and mitigate that pressure and shield yourself as much as possible, right? It's like if you had a house, you wouldn't leave your door unlocked, your windows cracked open for someone to get in, right? You would try to maybe have a fence around, lock your doors, have, a sort of a security system in place or security alarms in place when someone tried to break in or brute force in to keep you alerted that they've just broken in, to give you an added layer of protection. Maybe have all your valuables in a safe somewhere, your important valuables, right? So these are different ways that you could prevent, in the sense of cybersecurity, right, people from getting into your house in this case, right? So when we talk about the wide area network, right, we're talking about a wider network that connects to smaller networks or LANs, right? So local area networks. So you have multiple local area networks connecting to a bigger, wider area network, right, to create this internet of things, right? And so specialized computer systems perform special tasks like ATMs, remotely access computer systems, right? And yeah, so I don't even know why I wrote that, but anyways, let's move on to the next thing, right? So when we look at the input-output devices, right, what is that, right? So input-output devices are like headphones or payment terminals, right? Things you can plug into another piece of hardware and plug out of another piece of hardware, right? So CPUs do bulk of the processing in any computing device, right? So that's something that you need to know. So CPUs do the bulk of processing, right? And CPU speed is measured in gigahertz, right? Again, CPUs are typically anywhere from 32 to 64 bits, which we already discussed. And then power grids run on AC and computing devices run on DC, right? And yeah, so as we scroll and we continue on, we can see the storage capacity, right? So this is the important thing that you need to understand about, because people don't understand the difference between megabytes, kilobytes, gigabytes, terabytes, right? So 1 digit equals 1 bit, right? So 8 bits equals 1 byte. So again, 1 digit to 1 bit, 8 bits is 1 byte. 1024 bytes equals 1 kilobyte. 1024 kilobytes equals 1 megabyte. 1024 megabytes equals 1 gigabyte, and 1024 gigabytes equals 1 terabyte, right? And that's how that works, right? So we scroll down, so you can see here, single CD will have around 700 megabyte storage space, right? And a DVD will typically have around 4.7 to 8.5 megabytes of storage space. Then when you talk about Blu-rays, they'll have typically around 50 gigabytes of storage space, right? And so SSDs stand for solid state drives, right? And a NAS is a network attached storage. So what that is basically your own storage, right? For your own particular network that's separate from something that's on the cloud, for instance. Because the cloud, you're basically renting someone else's cloud software, right? And you're leveraging that to be able to store your data on their servers. So you're renting their servers, basically, right? Whereas a NAS, you can create your own cloud service yourself, and you can store things privately yourself at the comfort of your own home, right? So data usage, using cell phone towers to stream data to device. And you have storage, everything stored on a local device, right? And here you see there's 3 types of connectivity. So that's the wired, wireless, and cellular, right? And these are 3 different ways people connect. And as we scroll down here, we can see 7 important characteristics between the 3. So you have the mobility, right? How far you can go away before connection is lost, right? And then you have the availability, the reliability, and the throughput, right? So how good is the throughput of the data going in and out, right? The bandwidth of the data, right? The latency, how quickly does it get to the data gets transferred to the end user? Then you have the number of concurrent connections, right? And you have the number of security, right? So when we move on here, we can see a WAP is a wireless access point, and it creates connections between 2 or more laptops to create a network, right? So that's basically one of these intermediary tools that you can leverage to be able to create these 2 connection points between 2 laptops, right? And then you see a repeater allows you to extend the wireless network in the case of an event where the network cannot reach a specific location in the house, right? So basically, say for instance you're in a big house and the router is in the living room, but when you go upstairs, let's say, I don't know, to the attic, you then no longer have connection to the Wi-Fi. What you can do is you can buy a repeater, and it will basically extend the limit on the Wi-Fi signal into a wider area around the house, so then you have a stronger signal where the signals are weak in that pain point within the house, right? And that's basically what a repeater is, right? And so when you talk about spyware, so these are just different ways in which hackers, different tactics that they use. So they use spyware. So spyware gathers information about system usage. So what they'll do is they'll find a way to get and brute force into the system in some different kind of way. Sometimes they'll use a malicious USB, and that USB will actually have malware attached to it, and then it'll give them access to be able to see everything you're doing on the computer, and even they can then use the command line interface to make commands, right? And actually type on your computer and go through your computer. Basically, they have access to your entire monitor and your entire system, right? And yeah, so they also use keyloggers. So report keylogs. So basically that's what they do, right? The keyloggers are basically like ways in which you can brute force to find the actual password of a certain person that you need, right? You can attach a keylogger, and you can just and the keylogger will try different combinations until it gets one right, and then to be able to get access to whatever it needs to get access to. Then obviously I talked about ransomware already, and so like I said, it encrypts the data and holds your data ransom until you pay whatever it is that they want you to pay, and usually it's Bitcoin, like I said. And then what is this? Use IMAP rather than POPP for email because it's more secure. Okay, yeah, so here we go. Use IMAP or IMAP rather than POP3 for email because it's more secure of a protocol, right? So something to keep in mind. And then a firewall stops bad actors from getting into your computer. Just another thing that I wrote down in my notes. So in the case of an event that your computer has a virus, these are the steps that you should take, right? For people who don't know, you quarantine your computer, and then you download software to clean your system for you, right? Whatever, Apple is easy to clean as opposed to Windows. Windows, you can use a software like McAfee or something, right? So you download that software and then you have it clean your computer completely, from the virus. And yeah, so when you scroll down here, you can see the type disk cleanup to clean up your hardware and save space. Yeah, I don't know why I wrote that, but yeah. So when you move on here, see the task manager, right? So you can check basically to see where you can end a task to increase RAM, right? from your task manager on your actual computer. So when you type in your computer, whatever operating system you're using, you can access the task manager to see, okay, why is my computer running so slow? Oh, okay, I need to exit out some of these applications that are just working and just running autonomously for no reason, right? To increase the speed in which your computer operates, right? And so an array versus a vector. So an array is a fixed size of something, while a vector is a variable size of something, right? And then you also have MAC, which is a media access control address, right? A collision domain can be separated into multiple collision domains with a switch. This helps to transmit data more seamlessly and decreases the chances for collisions, right? And yeah, so as we scroll down here, we talk a little bit more about IP. So IP gives the packet to the right computer, and UDP, the user data gram protocol, right, gives the packet to the right program, right? All right. So again, the IP gives the packet to the right computer, and the UDP basically deciphers. Okay, basically what ends up happening is data gets transferred to a specific IP, but then there's so much data being transferred to that IP at a time, whether that's emails or whatever. The UDP separates that data, right? It separates the data to give the right packet of data to the right program, whether that's email or a video game or a Skype or Zoom call or whatever, right? Because some data is so large sometimes, and this is how computers get slow, right? What ends up happening is there's a whole bunch of different data that's all trying to go into. So say for instance you have a piece of data that you want to transmit to somebody, right? What's ended up happening is they split that data because it's quicker that way, because the routing systems it's too small. So they split it up into different packets, right? And these packets all are meant to arrive at one singular point, which is the IP address, right? And so basically that's why sometimes the packets may arrive at different times, and this causes, for instance, that's why when you Zoom call or you video chat with somebody, it might freeze up or something, because all this data is being transmitted all into the IP, and sometimes some of the packets don't arrive in time. But it doesn't matter, because the UDP will organize those packets in the correct order that they should be in, right? But like I said, sometimes it's slow because the throughput's slow or the bandwidth is slow or whatever, right? And that's basically how that works. Then you have the TCP, which is the transmission control protocol, right? And yeah, so this is used for packages that absolutely have to get to the end destination, such as an email, right? It will put the packets in the right order so they can reach the destination unscrambled, right? So that's what the TCP does. So because it's a little bit nuanced if it's an email, right? It has to be all packaged in the right thing, otherwise it will come kind of messed up, And so if an email comes in all scrambled, it will reorder the data. It's exactly what I was talking about, right? So the TCP will do that, right? It reorder the data correctly before sending it off to the correct application to be viewed by the end user, right? When your computer wants to connect to a website, it needs two things. It needs the IP address and the port, right? So if it's a secure browser, it'll be HTTPS, which would be the port would be 443, and an IP address, right, which is the identifier for that website, right? And DNS is a domain name server, an easy replacement name, right? For instance, like youtube.com, so you don't have to remember the website IP, right? So you could technically type in for every website their entire IP. But I think the same thing is going to happen with the public addresses in crypto, right? I think the public addresses are too long to remember. And yeah, they deduced stuff like QR codes and all these different types of things, but then maybe people will make pseudo-anonymous aliases, right? Like, I don't know. Something like a Glassdoor 37 or something like that. Something easy for someone to understand and transfer the data more seamlessly. And you could just type in that DNS or that domain name and be able to easily identify the different domain names, right? Like now we have like YouTube and Netflix, so many different domain names instead of typing in the IPs like 173.77.465, blah, blah, right? And so there's 7 layers of the open system interconnection, right? So they are application layer, the presentation layer, session layer, transport layer, the network layer, data link layer, and physical layers, right? So the uniform resource locator, right, or the URL, right, has a port number of web servers, right, and web servers is port 80, right, again, and server can ask web server for hypertext, right, which is the HTTPS. So hypertext markup language, which is, so basically that's a coding language to create basic text on websites, right? And so web crawler indexes, and so a web crawler, right? That's basically something that indexes and scans the web for data to add to the search engine. That's why Google crawls data all the time, right? So sometimes it takes a while when you fire up a new website for it to crawl and implement that data set, right? It takes some time because they have web crawlers that are doing that constantly, right? So it takes time for it to update because there's over 1 billion websites and so on, right? So index is identified what terms and links the crawler finds and what pages it finds on them, right? So search engine, it consolidates the data, making it easy to identify what you are looking for when typing it in, right? So Google, so here's the thing, right, with the search engine, right? So again, it's a consolidated data set that makes it easier for you to find what you're looking for, right? So for instance, people would back in the days sort of spam their websites with a whole bunch of keywords. Like for instance, if you had a cat website, you would put cats like a million times on your website. So then it would make you be one of the top people on the search engine. But Google got smart and they started leveraging backlinks to give websites more authority over others who spam keywords on their websites, right? And so this is what gave them the added advantage over the other search engine during the search engine wars, right? Because they were able to find a way to make more authoritative websites rank higher in the search engine, right? And yeah, so when we scroll down a little bit more, we can see that there's also network neutrality. So that's another thing too that I learned. So often referred to as net neutrality, right, is the principle that internet service providers, or ISPs, should treat all data on the internet equally. It means that ISPs should not discriminate against or prioritize specific websites, servers, or types of content by blocking, throttling, or providing preferential access. Net neutrality ensures that users have equal access to all online content and that the internet remains an open and level playing field for innovation, information sharing, and communication. So that's the thing, right? Some of these bigger companies have advantages where, they rank more higher on the search engines, or they're more favored in certain scenarios, right? Which they're probably paying, these search engines, or, these platforms to showcase their website more frequently than another website. So it makes it harder for small SMEs, small medium enterprises, to get more traffic within the internet, right? And so that's basically what network neutrality is to make it more of an even playing field amongst all the different websites and not sort of shadow ban these other corporations, which makes it harder for them to survive, right? Over the course of time. So what is cybersecurity, right? So cybersecurity is a set of techniques to protect secrecy, integrity, and availability of computer systems and data against threats, right? And yeah, so that's basically what it is basically what I am looking to build the skill set around, because I'm seeing that so many Web 2 and Web 3 companies are getting hacked, and I just want to be a part of it to help in regards to finding efficient ways and solutions for them to be able to defend them systems properly. And this is why I am going on this journey, to help as many businesses as I can in regards to that, right? So authentication, right? So when we look at that, it's a method to determine giving the right people access versus giving the wrong people access, right? And that's basically what it is, right? ways hackers breach a system, right? So there's different ways in which they do it. So as I told you guys already, social engineering, which is, they'll pretend to be somebody that works at a place or pretend to be a authoritative figure to try to convince people to give them access or higher level access into a company's networks. And once they have access to that, then it's game over, right? And then they'll plug in malicious code or do whatever they need to do to get the data they need, right? Or, to achieve whatever goal that they need to achieve, right? So pretexting is a form of social engineering where someone creates, a fabricated scenario or pretext to deceive and manipulate others into sharing sensitive information or performing certain actions, right? So this can be done through, let's say, like a call, right? Where they're telling you, like, hey, this is happening right now and it's not happening and they need you to do these things, these steps, and you believe it because you think it's someone from the security team or something, and then you make the wrong move, and then now they have access to things, right? And that's basically how that works. Malware is just basically like malicious software or code, right? Viruses and things of this nature, right? And ransomware, as I've already explained a couple times already, you guys got to deal with that, right? It's just basically, again, encrypting company data and then asking for a ransom to then release the data back to the company. And, they have brute force passwords too as well, where people literally use like keyloggers and all these different types of ways to brute force their way into the system. Different kinds of exploits. And then they have buffer overflow, which is a computer security issue that happens when a program tries to store more data into a temporary storage area, right? Or buffer. Then it can hold, right? And think of it like trying to pour too much water into a cup until it spills over. This excess data can overwrite other parts of computer's memory, right? Potentially causing errors or vulnerabilities that attackers can exploit to run malicious code again or take control of the system, right? And then, the code injections, and then they also do DDoS attacks, right? Which is basically send a flood of dummy messages to a server, right? At one time to basically overwhelm the server. And so basically the company, it slows down the production of the business, right? Or the software or the company, right? Overall, because their systems are just much slower because they've overran it with dummy messages to the server, right? And I want to close off with just saying this again. Another thing to keep in mind in regards to cybersecurity is that the market size is projected to grow from around 172 billion in 2023, right, to 424 billion, right, in 2030, at a compound annual growth rate of around 13.8%, right? And I do have, again, resources here too that you guys can look at. If you guys are interested in stuff like this, I will leave resources for you guys, right? But yeah, this basically is the conclusion for this After Hours, man. I hope you guys enjoyed this one, found it valuable. Stay tuned to the next one. See you, Space Cowboys, and peace.